Welcome to EDU World Space.
In this question, we are given that the boat can travel at 16 kilometers per hour in still water, and then the dash line, we are given this situation, and the dash line is the course that the boat needs to stay, and we are also given that the water is flowing downward with a speed of 4 kilometers per hour. We need to find the angle theta such that the boat can stay on course. Okay, so to do this, first we need to write down some of the given quantities. This is a relative motion problem. Okay, so uh, the boat is able to travel at 16 kilometers per hour in still water. That is actually the magnitude of the velocity of the boat relative to water. Okay, and then we are also given that the velocity of water Vw is negative 4 j hat kilometers per hour. Okay, then we recall the definition. So to find theta, okay, one thing is that along the course, okay, so Vb is going to be Vb cosine 70 degrees I hat plus sine 70 degrees j hat. Okay, this is the velocity of B that the velocity of the boat that the boat needs to stay in the course. Okay, and then we also have Vb slash W. This is the velocity of boat relative to the water. It is defined to be Vb minus Vw. Okay, so we are going to say that this is Vb cosine 70 degrees I hat plus Vb plus 7 Vb sine 70 degrees plus 4 j hat. Okay, this is evaluating the right hand side, and then the left hand side we are going to say that this is 16 sine theta I hat, okay, plus 16 plus cosine theta j hat. Okay, so we have two equations. Okay, so the first equation is 16 sine theta is Vb cosine 70 degrees. Okay, we also have 16 cosine theta is equal to Vb sine 70 degrees plus 4. Okay, so tangent theta is equal to Vb. Okay, so Vb is the one that we don't need. Okay, so we try to eliminate Vb. Okay, so from 1, okay, Vb is equal to 16 sine theta divided by cosine 70 degrees. Okay, so put it into 2, we have 16 cosine theta is equal to 16 sine theta tangent 70 degrees plus 4, right? So just make it easier. We have 4 cosine theta equals to 4 sine theta tangent 70 degrees plus 1. Okay, so the next thing I'm going to do is to make I'm going to write cosine theta as square root of 1 minus sine squared theta equals to 4 sine theta tangent 70 degrees plus 1. Then going to square both sides. 16, 1 minus sine squared theta is equal to 16 sine squared theta tangent 70 degrees square plus 1 plus 8 sine theta tangent 70 degrees. Okay, so so right now we can rearrange, group the sine square term together. So 16 sine squared theta tangent 70 degrees plus 1 tangent square 70 degrees plus 1. And then we have plus 8 tangent 70 degrees sine theta minus 15 is equal to 0. Okay, so now it's good to calculate some numbers. Okay, so if I remove, so I'm going to divide 16 throughout. So I have sine squared theta 1 plus tangent square 70 degrees, okay, plus 0.5 tangent 70 degrees sine theta minus 15 over 16 equals to 0. Okay, and then 1 plus tangent square is secant square 70 degrees plus 0.5 tangent 70 degrees sine theta minus 15 over 16 equals to 0. Okay, then you can use the quadratic formula. Okay, okay. So if you calculate this, you get sine theta is equal to 0.260 or negative 0.42. Okay, so this is not applicable. So sine theta is 0.260. Theta is equal to 15.1 degrees. Okay, so this is the answer. Okay, so this is the angle that that we are asked to solve on the diagram. Okay, so that's how we find the angle, and that's it.